Hi, today we will be covering midpoint theorem and ratio theorem. Now if there's a line and these 2 points A and C are on the line, what is the coordinates of B if B divides AC equally into 2 equal parts? Now if you look at these two triangles ABX and BCY, you will find that this angle will be equals to this angle because these two lines are parallel. Let's say we will draw two triangles such that these two lines are parallel to the x-axis and these two lines are parallel to the y-axis. Then you'll find that this angle will be equal to this angle, and this is of course 90 degrees. Alright, and this angle will be equals to this angle here. Now if it divides the length into 2, you will find that these two triangles are actually congruent. Okay, now triangle A B X is congruent with triangle BCY. Now if they are congruent, then AX will be equals to BY. Now so what is AX? AX is A minus X1. And what is BY? BY is X2 minus A equals to X2 minus A. Alright, now the A you can bring it to one side, so you have 2A will be equals to X1 plus X2. So A is equals to X1 plus X2 over 2. Let us try to find the y coordinates of B. Now BX will be equals to CY. BX will be equals to CY because these two triangles are congruent. So what is the length of BX? BX is B minus Y1. And what is CY? CY is Y2 minus B. So you have 2B will be equals to Y1 plus Y2. And B is equals to Y1 plus Y2 over 2. Okay? Now there's a simple way to find the midpoint of A and C. Now if the coordinates of A and C are given to you, now to find the x, you just take the average of the two x coordinates. So x1 plus x2 divided by 2. And the y coordinate, likewise, you take the y coordinate of A plus the y coordinate of C divided by 2. That means you are taking the average of the x's and the y's. Alright, so we have finished the section on midpoint theorem. We shall now go on to ratio theorem. Now ratio theorem is very similar to midpoint theorem. Midpoint theorem, you have the point B is in between A and C. Now same thing, B is on the line segment of AC for ratio theorem, but it is not at the middle of A and C. Now let us try to find the coordinates of point B. Now look at this triangle ABX and BCY. Let's call this Y. Okay. Now you look at the triangle, you realize that this angle here is equal to this angle here. Okay. Now because these two lines are parallel, and this angle here is equal to this angle here. So what can we say about triangle ABX and BCY. They are similar. Alright, so triangle A, B, X is similar to triangle B, C, Y. Now, so we can use R over S will be equals to AX over BY. Now, what is AX? AX is A minus X1. A minus X1. Now, what is BY? Now, BY is X2 minus A. Alright, so we can do a cross multiply and we make A the subject of the formula. So you have R X2 minus R A is equals to SA minus S X1. Now all those A, with the A you can bring it to one side. So you have SA plus RA is equals to R X2 plus S X1. Then you factorize the A out and you bring it to the other side. What do you have? You have R plus S. Okay? Now, if you look at it, it's like, you know, this times X2, R X2, S times X1 over the sum of R and S. Alright, this is the ratio theorem. Now we can do the same thing for Y. For Y, R over S is equals to AX. What is equals to BX over CY. Sorry, is equals to BX over CY. Now, what is BX? BX is B minus Y1. B minus Y1. Now, CY is Y2 minus B. Okay? Now, we can do a cross multiply. So, you have R Y2 minus RB equals to SB minus SY1. Now, if you do the same thing, those with the B you bring to one side, alright, without B you bring to the other side and you make B the subject of the formula. You will realize that B is equals to RY2 plus RY1 plus SY1, sorry, over R plus S. Alright, so look at the formula. For B, you use for B, you use R times Y2 plus S times Y1 over the sum of RS. Now, if you cannot remember this formula, you can just do it using similar triangle. Okay? Now, this is quite common. Alright? We are often given 2 points. Then you are asked to find another point that is along the same, lies along the same line given the 2 ratio. So what you could do when you see such a thing, we can make use of similar triangle. For that, we have come to the end of this lecture. Thank you very much. Thank you for watching.